Hi, I'm Talia. I'm an incoming college freshman at UCSD majoring in chemistry. This YouTube channel is an extra resource for anyone who may be needing some help with their chemistry classes. This week, I'm going to be introducing acids and bases and talking about pH, pOH, and how to calculate them both. So I hope that if you need help with those topics, you will keep on watching. And without further ado, let's get started. Okay, so before we go over how to calculate pH and pOH, you gotta know what pH and pOH are and what is the difference between them. And then before you know what pH and pOH are, you gotta know what acids and bases are, as this unit is about acids and bases. Okay, so some critical characteristics about acids and bases. I'm not going to go through all of these, I'm just going to go through the main ones. First, acids dissociate to give H plus ions, and bases dissociate to give OH minus ions. And acids have a pH that's less than 7, and bases have a pH that's greater than 7. And then we also have acid-base indicators. So all this stuff here are acid-base indicators, and acid-base indicators are used to show if an acid or base is present. So based on the color of the indicator, you can tell if the solution is basic or acidic. So if you put phenolphthalein in a basic solution, it will turn pink, but if you put it in an acidic solution, it will be colorless. So now let's go one step further and talk about pH and pOH. pH is the power of hydrogen, and it measures how acidic a solution is. So when the pH is lower, it's a more acidic solution, which would make you think it's a little counterproductive because you'd think more pH, more acidic solution. But it has to do with how calculating pH and pOH has to do with logarithms. And when you have a lower pH, you are going to have a higher concentration of H plus, because if you do 10 to the negative pH power, that is going to give you the concentration of hydrogen. So if you have 10 to the negative 5 power, that's going to be a lower concentration of hydrogen than 10 to the negative 4 power. So therefore, when you have a lower pH, you're going to have a higher concentration of hydrogen. So in an acidic solution, the pH is less than 7, and the concentration of hydrogen is greater than the concentration of OH minus or hydroxide. Now we have pOH, which is the power of hydroxide, and this works the same way as acidic solutions but flipped. So this measures how basic a solution is. When you have a lower pH, there's a more basic solution. For the same reason as the hydrogen. If you want to calculate the concentration of OH minus using the equations I have over here, just like we did with H plus, the higher number you plug into your exponent, you're like 10 to the negative 6 versus 10 to the negative 4th power, the 10 to the negative 6 is going to give you a lower concentration of OH minus because it's 1 over 10 to the 6th. Whereas if you have 10 to the 4th, 10 to the negative 4th, that's 1 over 10 to the 4th, which is not huge, but a higher concentration than 1 over 10 to the 6th. Therefore, when you have a lower pOH because of the negative pOH power, that is going to give you a more basic solution. So as I said, pH and pOH are on a logarithmic scale. So every change in one pH scale is a change in acidity by a factor of 10. Now let's calculate pH and pOH. I kind of touched on this when I was explaining what they are, but you can convert in between them in a bunch of different ways. pH is the negative log of the concentration of hydrogen, which means that hydrogen is 10 to the negative pH power, if you want to rewrite the pH equation as an exponent. And the same goes with pOH. And then pH and pOH are always going to add to equal 14, and that means that the concentrations of hydrogen and hydroxide are going to multiply to equal 1 times 10 to the negative 14th. Also, pH and pOH don't have units, and the sig figs with pH and pOH start after the decimal place. So now let's calculate the concentration of hydrogen and hydroxide in these solutions and classify them as acidic or basic. So first we have cola with a pH of 3.5. We already know that if the pH is less than 7, it's going to be acidic. So we know the answer we're kind of looking for, but let's calculate the concentration of hydrogen anyway. So we know that the concentration of hydrogen equals 10 to the negative pH power. So 10 to the negative 3.50. I'm going to plug that into my calculator, which is going to equal, I have 3.162277766 times 10 to the negative fourth, but my pH has 2 sig figs, which means that my concentration is also going to have 2 sig figs. So 3.2 times 10 to the negative fourth, and concentration does have units of molarity. So even though in the pH there are 3 numbers, the sig figs only start after the decimal place, so there are only 2 sig figs, which means that needs to apply to the concentration. Okay, so now that we have the concentration of hydrogen, let's figure out the concentration of hydroxide so we can know which one is larger, and then we can classify if the solution is acidic or basic, because in an acidic solution there's more hydrogen, and in a basic solution there's more hydroxide. So you can do this a number of ways. The way I'm going to choose to do it is write that the H plus times the concentration of OH minus is going to equal 1 times 10 to the negative 14th. So 3.2 times 10 to the negative fourth molarity times the concentration of OH minus is going to equal 1 times 10 to the negative 14th. And then I'm going to divide both sides by 3.2 times 10 to the negative fourth. So 1 times 10 to the negative 14th divided by 3.2 times 10 to the negative fourth is going to get me 3.1 times 10 to the negative 11th molarity. And also we can see, obviously, that the concentration of hydrogen is much larger than the concentration of hydroxide. Therefore, because the concentration of hydrogen is greater than the concentration of hydroxide, the solution or the substance is acidic. Let's do our next example. Vinegar with a pOH of 11.60. So the pOH is greater than 7. So that means the pH is going to be less than 7. So we can kind of get a hint this is going to be an acidic solution. I'm going to still find the concentration of H plus and OH minus. I'm going to go about it a different way just so I can show you all the different things you could do. So I'm first going to find the concentration of OH minus. So the concentration of OH minus is going to equal 10 to the negative pOH power. So we have 10 to the negative 11.60 power, which is going to equal 2.5 times 10 to the negative 12th molarity. And remember, there are 2 sig figs here. So instead of doing H plus times OH minus like I did in the last example, this time I'm going to find the pH and then find the concentration of H plus. You use different equations depending on what you're given and what's easier for you. I'm just going to show you everything. Okay, so I'm going to calculate pH. So I know that pH plus pOH equals 14.00. So that means that the pH plus 11.60 is going to equal 14.00. So I'm going to subtract 11.60 from both sides, and I'm going to get that the pH equals 2.40. So now let's calculate the concentration of H plus from there. So the concentration of H plus equals 10 to the negative pH power. Also, these equations are on your formula sheet normally for honors chem. So then that means it's going to equal 10 to the negative 2.40 power, which is 0.0040 molarity. Remember, this is still 2 sig figs. Okay, so our concentration of hydrogen is higher than our concentration of hydroxide. So once again, the substance is going to be acidic.
Okay, so I'm also going to show you how to calculate pH and pOH from the concentration of a solid. So we're going to do an example with 0.50 molarity of hydrobromic acid. So I need to calculate the concentration of H+, but we know that hydrobromic acid dissociates. So I'm going to write a dissociation equation. So HBr dissociates into H plus and Br minus. So if the concentration of HBr is 0.50 molarity, then that means the concentration of H plus will also be 0.50 molarity. So now let's calculate our pH. So we know that pH is the negative log of our concentration of H plus, which would be negative log of 0.50 molarity. So we're going to do negative log of 0.50, and this is 2 sig figs, which means that our pH is going to be 0.30. Okay, so now to calculate pOH, we know that pH plus pOH equals 14. So I have 0.30 plus pOH equals 14. And then our pOH is going to equal 13.70. Let's do one other example with BaOH2. So BaOH2 dissociates into Ba2 plus 2OH minus. So if the concentration of the whole ionic compound is 0.010 molarity, that means that my concentration of hydroxide is going to be 2 times 0.010, which is 0.020 molarity. And obviously the concentration of Ba2 plus will be 0.010 molarity. So first I'm going to calculate pOH, just because I'm starting with OH. I think it's a little bit easier. So our pOH is going to be the negative log of the concentration of OH minus, which is going to be the negative log of 0.020. And that's, again, 2 sig figs, so my pH is going to be 1.70. Now I'm going to use a different method to calculate my pH. I'm first going to calculate my concentration of hydrogen. So we know that the concentration of hydrogen times the concentration of hydroxide is going to equal 1.0 times 10 to the negative 14th power. So the concentration of hydrogen times 0.020 going to equal 1.0 times 10 to the negative 14th. So I'm going to divide both sides by 0.020 molarity. And then I'm going to divide 1.0 times 10 to the negative 14th by 0.020 molarity. And I get that the concentration of hydrogen is 5.0 times 10 to the negative 13th molarity. Now we're not done yet. We want to calculate pH. And to do that, I'm going to do the negative log of the concentration of hydrogen, which is the negative log of 5.0 times 10 to the negative 13th molarity. Which is 12.30. So those are two different ways to calculate pH and pOH given the concentrations. Again, like I mentioned earlier, the different equations can help you in different ways depending on what you're given on the problem. So it's good to know how to use all the different equations, which is why I did the different problems differently.
So that concludes this week's video. In my next video, I'm going to talk about acid-base stoichiometry, which is basically strong base, strong acid titrations. So if you would like to learn more about that, feel free to join me back next time. I hope you enjoyed this week's video, and as always, feel free to leave any questions or comments you have in the comment section below. Good luck with learning the rest of your chemistry.